Hello students. During my EG class, some of the students raised few questions regarding the solids. So the solid can be rest on an edge or on a corner. Okay. So they are confused about these two conditions and they have asked how to draw the basic position. Okay. So now I'm going to do a video on that. So before going to the solids, we will see the basics of a projection of line. That's very important. Okay, so these are all the four quadrant. We have already know this. So vertical plane and horizontal plane. If a point is resting on first quadrant, say y, okay, this is the point y, which is 10 mm above and 20 mm in front. This is how we will denote this point, right? So now we will zoom the first quadrant. Okay, so this is the first quadrant. VP and HP is there, and the intersection of these two planes are called XY, right? Now there is a point which is on the first quadrant. Okay, so the position of this point can be expressed above HP and in front of VP. So this is the yellow color line which denotes the point's position with respect to HP, right? So 20 mm above. A is 20 mm above, and this red color denotes the in front position, that is 30 mm in front of VP. Okay, so the front view and top view is given here. The front view, we can get the front view 20 mm above this XY line, and the top view can be seen from the top, and the top view is 30 mm in front of VP, so which comes below the XY while we tilting this HP. So the HP is tilted 90 degree, and the front view is seen like this, that is 20 mm above the XY, and the top view is 30 mm in front of VP. So you can see above HP means we need to draw the point above the XY line, and in front means we need to draw the point below XY. This is the point, and now we are going to see the same for a project of a line. Okay, AB is the true length of the line, and front view will be seen on VP and top view will be seen on HP. Okay, this is the front view and top view. So alpha is the angle made by the front view, beta is the angle made by the top view. Okay, and you can see A dash and B dash is used to denote the front view, A and B is used to denote top view. In top view you should not use dash. Okay, that's the conventional type of mentioning the front view and top view. Okay, and then you can see there is a vertical line drawn between these two. So now they are removing the true length, that is capital AB, and then the HP is tilted such that A dash and AB lies in a same vertical line, B dash and B lies in a same vertical line. These two lines are called end projectors. Your front view and top view will always be in a same vertical line, that is called end projectors. So from these, how one can able to get the true length? We have obtained the front view and top view. From this we need to get the true length. Okay, we can see here. So first, from the top view we are getting the true length in the front view. Okay, so the top view is given here, and then the top view is tilted such that which is parallel to XY. So இங்க இருந்த top view வந்து now made parallel to this XY. Okay, so and then now from this B, this B is tilted here. From this B we are drawing a vertical line up to the locus of B dash. From B we are drawing vertical line to B dash. Okay, you can see here. So now we are joining A dash and B dash. By joining these two we will get the true length. This is the true length. Okay, and then front view is also there. which is not visible to your eyes. Okay, from the front view we are going to get the true length. So it's inversely given. For example, this is the front view. From the front view we have this front view is made parallel to xy. This is the arc. Okay, so this a dash and b dash made parallel to xy, and then from this b dash we have drawn a vertical line up to the locus of b. Okay, wow. So from we have got this point. By connecting a and b1 we will get the true length. This is the procedure for obtaining the true length from the front view and top view. In few cases, from the true length we will get the top view and front view. In some cases like this, they will give the true length. From the true length we will draw a vertical line like this up to the locus of locus of A. From here we will draw an arc so that we will get the front view. This is the front view. Okay, so this is the procedure to obtain the front view and top view from the true length. Okay, and next here come to the solids. So a solid whose axis is denoted with respect to the position. So this is the axis of the cone. The axis of the cone is perpendicular to HP and parallel to VP. So in your front view you can able to see the rectangular portion, and top view you can see a circle, okay, with the apex. So this is the position of a cone, and then this is the position of a cuboid. Okay, in your front view and top view you can see the square. And next one, a square prism whose axis is perpendicular to HP and parallel to VP. So in your top view what you can able to see is the square. From the top view you can able to see the square, and in your front view you will see this hollow section, that is rectangular part. This is the front view and top view for the square prism whose axis is perpendicular to HP parallel to VP. Here a hexagonal pyramid whose axis perpendicular to HP and parallel to VP. So in your front view you can see the triangular part, and top view you will see a hexagon. So in your top view you will draw a hexagon, and then you will draw a triangle in your front view. Now the axis is perpendicular to VP and parallel to HP. So in your front view you will draw a square, and then top view you will see a rectangle. So similarly a hexagonal pyramid whose axis is perpendicular to VP and parallel to HP. So front view you will get a hexagon, in your top view you will get a triangle like this. So this are a simple position whose axis is perpendicular to one axis and parallel to another. Okay, so this is an example, a hexagonal prism whose axis is perpendicular to VP parallel to HP. Front view la you will get hexagon like this. So in this case they will made a statement, that means one rectangular edge or edge of the base will be parallel to HP. You can see this is the HP. For this HP, that means horizontal plane, one of the rectangular face is parallel. This face is parallel, so that you need to draw this edge should be parallel to XY. Okay, so these are all some of the condition they will mention. And you can see this is a square pyramid. Square pyramid whose axis is perpendicular to VP, parallel to HP, and the base square whose edge is inclined to HP. You can see the base edges making 30 degree with the HP. So in your front view, you need to draw a square like this, whose axis is 30 degree inclined to HP. So inclined to HP means you need to draw the inclination above XY. So inclined to VP means you need to draw the inclination below XY. Okay. So in your front view, you will get a square, and top view you will get a triangle. Okay. So these are all the basics of the projection of solids. Now we have come to the question, so which is resting on its base corner, whose axis is inclined. This is a hexagonal prism. So from this edge to this edge we have the axis. This axis inclined to HP. Okay. So what we have to do is, first we need to make the axis perpendicular to that. That means if the axis is inclined to, given axis inclination is given with respect to HP, right? Axis inclination is given with respect to HP. Okay. Now what we have to do is, we have to consider the axis is perpendicular to HP. So axis perpendicular to HP means in the top view you will get the hexagon, and front view you will get the triangle. Okay, it is resting on one of its corner. That means one point is at this end. One point, corner means one point, edge means line. Okay, you can see. So in your top view you will get a hexagon like this. Okay, so one corner is here, and front view you will have a rectangle. So now we are tilting. So it is given in the opposite direction. You can tilt in the opposite direction also. Sorry, you can tilt in this opposite direction also. So now we are tilting the hexagonal prism such that one of the corner is touching on the ground. Sorry. So one of the corner is resting on the HP. So now we incline the axis, and this is the final projection.